In this video, I'm going to illustrate how to carry out a factorial MANOVA and also a couple of follow-up options to the MANOVA tests. So in this example, I have basically two independent variables that are both categorical, which are intervention, which basically when we look at this particular variable, we have three levels. We have intervention A, B, and C, which are coded 1, 2, and 3 in our data set. We also have a second independent variable, gender, which is, again, categorical, and it's coded 1 for male and 2 for female. And then we have three dependent variables, which are all assumed to be continuous. So in our factorial MANOVA, the independent variables are assumed to be categorical and the dependent variables are assumed to be continuous. So at any rate, what we're looking at is the effect of intervention on the set of dependent variables. We're also looking at the effect of gender on the set of dependent variables. So the tests of these are basically each of these independent variables is referred to as a main effect. And then we're also going to look at the interaction between intervention and gender and its relationship to the set of dependent variables. So to run the basic MANOVA, what we'll do is we'll go to Analyze, General Linear Model, and Multivariate, and essentially we'll move intervention over to the to the fixed factors box along with gender. We'll move self-efficacy, perceived utility, and intrinsic motivation to the dependent variables box. So if we can imagine, let's say intervention is referring to a type of educational intervention designed to improve students' levels of self-efficacy, their perceived utility of school, and their intrinsic motivation related to school. We're looking at, so in that case, we're looking at the effect of intervention and also gender, and then also trying to determine if gender might moderate the effect of intervention on the set of dependent variables. So when we start asking about moderation, that's where we start looking at the interaction term in the model. So under options, we'll click on basically all of these and move these over to the display means box, because we'll need we want means for the different levels of intervention, the different levels of gender, and then also the interaction between the two. We can ask for descriptives, effect size, power, and homogeneity of covariances assumption is also a requirement for the MANOVA. So I'll click on Continue, and under plots we can ask for essentially univariate plots. So I can ask for a profile plot for the means for intervention. I can ask for a profile plot for the means associated with gender, and then also a plot for the interaction between intervention and gender. So I can click on that and get that. So at this point, I'm going to go ahead and click on Continue, and basically there are various post hoc options that can be utilized in order to follow as post hocs to the univariate follow-up tests that are presented by default in SPSS. So one example might just be if I click under here, I can click on for intervention, move this over to post hoc tests, and I can click on Tukey, and I can get post hoc tests for Tukeys. It doesn't make any sense to move gender over here because there are only two levels of gender, and so if the univariate ANOVA follow-up is significant, that would obviously mean that males and females are different on the dependent variable. But again, because intervention has three groups, then this might make sense to request post hoc tests. Keep in mind that SPSS defaults by giving you univariate follow-up tests to the MANOVA, and in a sense they kind of violate the spirit of the MANOVA, but these are typical follow-ups that people utilize, and so I'm giving you this as a way of demonstrating how these are arrived at. So I'm going to click on Continue and then on OK. And so you can see right here we have our descriptive statistics, and so you can see for each dependent variable there's self-efficacy, there's perceived utility, and there's intrinsic motivation. And so what you have right here, you have cell means, okay, and cell standard deviations for scores on each of the dependent variables um, for each combination of intervention and gender. So basically, for those individuals who were receiving intervention A who happened to be males, the mean for those individuals was 51. Standard deviation for those individuals was 3.1. And the sample size for that cell was 20. For intervention A individuals who were also female, the mean was 56, standard deviation of 3.2, and sample size of 19 for that particular cell. So basically, females scored higher on self-efficacy than males in the intervention A condition. In the intervention B condition, you can see, again, here's the mean for males is 58. There's the standard deviation. The mean for females was 46. So actually, males scored higher than females on self-efficacy in the intervention B condition. There's our standard deviation again. In the C condition, you can see that males and females actually score fairly close together, with females scoring just a little bit higher than males. And again, there's our standard deviations for those. These are the sample sizes for each of the cells. Okay, for perceived utility, you can see that in intervention A, males and females scored exactly the same. In intervention B, you can see that males scored higher than females on perceived utility, and in intervention C, you can see that males scored lower than females. And again, you have your standard deviations for each of your cells in the model, as well as the sample sizes. Then you have intrinsic motivation. So for intervention A, who are males, you can see that those individuals scored 24 on average. The females scored 29 on average. So they were higher on intrinsic motivation than the males. In intervention B, you can see that males scored higher on average than females for intrinsic motivation. And then for intervention C, you can see that males scored lower than females on intrinsic motivation. So you can see that essentially you have some mean differences for self-efficacy, utility, and intrinsic motivation. We can't say that these are significant differences, however, because we haven't actually carried out the inferential test. But these, descriptively, these are the means for the different groups. So when we want to look at the effect of just intervention on, or just look at differences between intervention groups across levels of gender for self-efficacy, then what we'll want to do is to look at this mean right here. So this is the mean self-efficacy score for those individuals in intervention A. This is the mean self-efficacy score for those individuals in intervention B. And this is the mean self-efficacy score for individuals in intervention C. Here we have the mean for utility score for intervention A, the mean utility for intervention B, and the mean utility for intervention C. And then we have, again, the mean for A for intrinsic motivation, B, and C. So essentially, these means right here. This is what the main effects tests are basically going to be addressing. Are the differences in means for intervention. You also have another main effects test concerning gender. So down here, you'll notice that you've got total for males. So the mean for males was 53.21 on self-efficacy. The mean for females was 51.7586. So males were scoring higher on self-efficacy than females. When we look down for perceived utility, you can see that males scored a little bit higher than females. And then when we look at intrinsic motivation, again, males scored a little bit higher than females. So basically, like I said, when we're looking at the MANOVA results, there are three effects that will be tested in this model. There'll be the test of the effect of intervention, and so essentially, what this is involving are the comparisons of these means right here across your three dependent variables. There'll be a main effects test of gender, and that will involve comparisons of essentially, excuse me, actually down here, the comparisons of males and females across levels of across our dependent variables, and then there will also be a test of the intervention by gender interaction. So at any rate, those are the means that are basically being involved in our MANOVA comparisons. So kind of scrolling down, you'll see that we have our MANOVA test results. So you can see this is a test of the main effect of intervention on the set of dependent variables. We have the main effect of gender being tested in terms of its impact on the set of dependent variables, and then we also have the interaction between intervention and gender as it relates to the set of dependent variables. Keep in mind that the MANOVA tests make the assumption of homogeneity of covariance or variance-covariance matrices, and so this is what the boxes test is presenting up here. So what you are essentially, this is a p-value, and what you are essentially looking for are p-values that are greater than, say, 0.05. If the p-value is greater than, say, 0.05, then you might infer that the variance-covariance matrices across the levels of your different variables, your independent variables in the interaction, are equivalent. So that's actually a good thing. If, let's say, p was less than 0.05, then that would call into question that assumption being met, and that would then call into question some of the inferences that you could draw related to the main effects as well as the interaction effect. So looking at the effect of intervention, I'm just going to go ahead and utilize Wilks lambda as my test statistic. So this is the Wilks lambda value looking at the main effect of intervention on the set of dependent variables, and you can see that the test of the effect of intervention on the set of dependent variables indicated that there were significant multivariate group differences on the dependent variables. So there were overall significant differences among your groups across the set of the dependent variables. The partial A squared column is basically reflecting effect size, and so using Cohen's conventions for judging the magnitude of effects, where you have 0.01 for small, 0.06 for medium. Whoops. Like that's a 0 there, and 0.14 for large, 1.4 or greater for large, then this would obviously suggest that we have a very large effect of intervention on the set of dependent variables. Then we have gender as our independent variable, and so here you can see that again there's our Wilks lambda value, and you can see that the effect of gender was statistically significant. And and when we look at the effect size, it was also quite large. So there seems to be a multivariate effect of intervention on when it comes to accounting for variation in the set of dependent variables. It looks like there's a multivariate effect of gender on the set of dependent variables. And then when we look at the interaction term, you can see here that it looks like that there is a statistically significant effect of the interaction between intervention and gender on the dependent variables. So what that basically means is that the relationship between intervention and the set of dependent variables changes across levels of gender. In other words, gender is serving as a moderator variable. keep in mind, I'm treating gender as a moderator variable, but theoretically speaking, I could have said that the relationship between gender and the set of dependent variables is being moderated by intervention. So the choice of the sort of the focal independent variable and the moderator variable is one of a theoretical concern. It's not mathematically. Both statements are true concerning the interaction between the two variables. So nevertheless, it looks like we have a significant main effect of intervention, a significant main effect of gender, and a significant interaction between intervention and gender on the set of dependent variables. And it looks like that really the effect sizes for each of those effects were large. Keep in mind that Cohen standards are utilized in reference to eta squared, and what that basically means is that there are a number of different effect size indices that can be computed for different statistical tests. So these conventions right here are in reference to eta squared. Also note that these conventions were formulated for the social and behavioral sciences. You probably want to, if you're not in those kinds of areas, you may want to consult rules of thumb or conventions for your respective field when you're trying to judge these values in terms of the size of the effects of the independent variables. So now scrolling down, you can see that by default SPSS gives you basically univariate ANOVA test results, and basically what you can see right here is you've got intervention, gender, and the interaction between the two. So as you can see, basically these represent separate factorial ANOVAs looking at the effect of each of the main effects on the dependent variables as well as the interaction. So briefly, let me show you what this looks like if I was just running a standard univariate ANOVA, a factorial ANOVA. The table, let's say I'm looking at the effect of these two variables on self-efficacy. So I'll show you what the table actually looks like. So you can see this is just a standard factorial ANOVA comparing the groups, the main effect of intervention, gender, and the interaction between the two on self-efficacy. So you can see you've got an effect of intervention, gender, and interaction between the two on self-efficacy. So these results right here are the same ones that are presented in the univariate follow-up tests that you see right here. So here's the effect of intervention on self-efficacy, here's the effect of gender on self-efficacy, and the effect of the interaction between the two on self-efficacy. So the values that you see right here are, in terms of the effect size and so forth, those same values are the ones that are reproduced if you were just running a standard one-way ANOVA. A standard factorial ANOVA that you see right here. So this is just to highlight what you're seeing up here in the default output given by SPSS. So you can see, again, the effect of intervention on efficacy, gender on efficacy, and the interaction between the two were statistically significant. The effect on utility for intervention was significant. The effect of gender on utility was significant at the 0.05 level, and the interaction between the two, that was also significant. And it also turns out that the effects on, for the main effects as well as the interaction were all significant when it came to looking at the group differences on intrinsic motivation. So basically everything was statistically significant when we consulted the univariate ANOVA follow-ups. So scrolling down, basically one of the things that I asked for was just the Tukey's post hoc comparisons comparing group differences on self-efficacy, utility, and intrinsic motivation. And so you can see that when we compared intervention A and intervention B, the mean difference column right here is I minus J. So it would be intervention A mean minus intervention B mean. So that's the mean difference, and you can see that that was not statistically significant. When you compare A versus C, you can see that the mean was about 2.14 points higher on average than C, and that difference was significant. When you compare intervention B versus C, you can see that intervention B was a little bit higher, had a higher mean than intervention C, but that difference was not significant. So concerning self-efficacy, you can see that there was only one pairwise difference in means that was statistically significant. When we look at utility, we've got intervention A versus B. No difference between those two groups on utility. Intervention A versus C, you can see that actually intervention C actually scored about 3.297 points higher on average than intervention A, and that difference was statistically significant. So C actually scored higher on utility than A. When we look at intervention B versus C, you can see that C actually scored higher on intervention on utility than intervention B, and that difference was also statistically significant. Then when we look at the effect on intrinsic motivation, looking at intervention A versus B, there was no difference in groups, even though there was a hint of a difference, mean difference. When we look at the comparison between A and C, you can see that A scored about 0.84 points higher on average than C, but that difference was not statistically significant at the 0.05 level. When we compare B versus C, you can see that intervention B scored about 0.95 points higher on average than C when it comes to intrinsic motivation, and that difference was statistically significant. So the two keys follow-up tests would be useful post hoc or exploratory analyses as follow-ups to the univariate ANOVA results that are presented up above. If you want to further look at the means using means plots, you can see for self-efficacy, you can see that there's intervention A, the mean for that group, B, and then C for this group, right? The mean for that group on self-efficacy. So, if we go back and we just kind of eyeball these tests right here, we saw A and B was not significant. There was not a significant difference. There was a difference between A and C, but there was no difference between B and C. So, kind of visually right here, you can see that there was no difference between these 2 points. There was no difference between these 2 points, but there was a significant difference between these 2 points. In terms of looking at the mean comparisons. Looking at the effect of gender, you can see that basically you can see that males versus females. If we go back and we look at the univariate ANOVA table, we saw that there was significant gender differences across each of the dependent variables. So this is just a plot of the means on self-efficacy, so you can see that males scored higher on self-efficacy than females. And then when we look at the interaction effect, the profile plot, you can see that males were in blue, females are in green, so you can see that males scored lower than females in when they were receiving intervention A. So you can see that there was a difference here. And then you can see that you have a crossover, right here, and so that now in intervention B, males were more receptive to the treatment, whereas females actually appeared to decline. So basically, females were less receptive. So in this particular case, I don't necessarily want to say decline, but they were less receptive. So you had a big mean difference here, and then you had a little bit more another crossover here, where basically males scored a little bit, females scored a little bit higher than males here. So if there was no interaction taking place, then essentially the blue and the green lines would be parallel. So you would have, for example, you might have something like this for the three groups, where essentially you could have, so if this was, say, males, and this was females right here, oops, well, pretend like it's parallel right here. So, an interaction would be reflected in, is reflected in lines that are not parallel to each other. So looking at utility, you can see here that comparison between intervention A and B. So we're looking at and B versus C. You can see that when we look at the difference in values between A and C and B and C, if we go back and we look back at our little Tukey's test, you can see right here, here was the A versus C comparison. There was a difference there, and then B versus C, and there was the difference there. So, as you're looking at the post hoc tests for intervention, those were so basically there was no difference here, but then both of these groups were significantly different from C. When we look at gender, you can see that essentially males scored higher than females, and then when we look at the interaction, plot of the interaction effect, you can see that males and females were not different in intervention A. You see that males scored higher than females in B, and then you have sort of a reversal or a crossover with intervention C, with there being a little bit of a difference here. Then when we look at intrinsic motivation, you can see that essentially intervention C had the lowest intrinsic motivation, whereas intrinsic A had the highest, and intervention B had intermediate levels. When we look at the gender, you can see that males were higher than females. And when we look at the interaction, again, you have these crossovers where basically, in this case, females were higher than males in intervention A, males were higher than females in intervention B, and females were higher than males in intervention C. So the long and short of it is that one set of strategies as a follow-up to the MANOVA, if the MANOVA is significant, and you're looking at those effects, is basically you would follow up by looking at the univariate ANOVAs, which are basically factorial ANOVAs, comparing main group differences on each of the main effects, in this case intervention and gender, as well as the interaction between the two independent variables. And then you could follow that up theoretically by looking at Tukey's post hoc tests to explore where those possible mean differences might lie, and then further looking at profile plots in order to describe the interactions that appear to be taking place that are indicated by the statistical tests.